As we gaze up into the night sky and marvel at the twinkling stars, we can't help but wonder about their origins. The universe, my friends, is a grand cosmic theater where stars are born, live out their lives, and ultimately meet their fate. Did you know that the galaxy types, giant ellipticals, spirals like our Milky Way, and even the irregulars all play a distinctive role in the grand performance of star formation? The birth of stars, an event that's been taking place for over 13 billion years, follows a rhythm that's been changing over time. It's akin to a cosmic orchestra that started out with a blazing fanfare, but has since slowly been dialing down the tempo. And get this, we are now experiencing the lowest point in the universal star formation rate in all that time. Now, those first stars that lit up the universe were not like the ones we're familiar with today. Picture enormous, metal-free giants fated to end their lives in a spectacular supernova. The early universe was teeming with potential for star creation, but it took time for these giants to form. The triggers behind star formation are not just external like tidal forces or debris from supernovas, but also galactic mergers, the universe's biggest star-making events. But alas, the universe is growing older, and the rate of star formation is dwindling. As galaxies group together, much of the material that could potentially birth new stars is stripped away. Additionally, the material within galaxies is getting heavier and therefore less conducive to star formation. Here's a fascinating tidbit for you. A recent study found that galaxies are taking longer to stop forming stars as the universe ages. Since the peak of star formation about 10 to 11 billion years ago, the rate has declined by a whopping 97%. But let's not lose hope. As long as there is gas and gravity, there will be stars. But one intriguing question remains. Well, you'll find out soon enough. What's up, my amazing and curious folks? Are you ready to unravel the mysteries of the universe together? I'm Caesar, your guide on this cosmic journey, and by my side is the ever-knowledgeable Sonia Guimaraes. Hit that subscribe button and ring the bell so you won't miss any of our deep dives into the universe's greatest puzzles.
Hey there, everyone. Looking forward to journeying through the stars with you all.
You know, folks, the story of star formation is like the grandest of symphonies. Picture it, a universe teeming with raw potential, much denser than today, but no stars, not yet. There were no brilliant points of light, just the raw ingredients for them. The universe was a cosmic kitchen, all set and ready to start cooking up stars. The most massive galaxies, the giant ellipticals, have largely stopped forming new stars. The spirals like our Milky Way are relatively quiet. And then there are the irregulars. These are the hot spots of star formation in the universe. Imagine galaxies transforming into sprawling star-forming nurseries, the birthplaces of millions of new stars. It's mind-boggling, isn't it? And yet, we're forming stars at the slowest rate in more than 13 billion years. The majority of stars were formed in the first few billion years after the Big Bang, with the star formation rate having dramatically decreased since.
You know, your description reminds me of a childhood memory. I remember lying in the grass in my backyard, staring up at the night sky. I'd trace out constellations with my fingers and marvel at the twinkling stars. It's fascinating to think that what I was actually seeing was the result of cosmic events billions of years ago. As a child, I couldn't grasp the enormity of it all, but I felt a sense of awe that has stayed with me to this day. I remember once, I spotted a shooting star and made a wish, as kids do. Now, understanding the vast process behind the formation of that single streak of light, it feels even more magical. It's this same awe and wonder that drives us to explore the cosmos, to unravel its mysteries. I feel incredibly fortunate to be part of this journey of discovery, and I hope we can inspire a bit of that childhood curiosity in our listeners to look up at the stars and wonder, just as I did.
When we think back to the early days of the universe, it's a bit of a paradox. You might expect that because matter was denser back then, there would have been more star formation. More matter, after all, would mean more chances for it to clump together and form stars. But there's a twist to this tale. Even though the universe was denser, it was also more uniform. the densest regions were only about 0.01% denser than any average density region. So it took time for these regions to accumulate enough matter to form stars and galaxies. The process of star formation is like a cosmic dance. A large amount of mass gathers in the same spot, cools, and collapses, and presto, a new star-forming region is born. This process can be triggered by different events, such as tidal forces from a massive nearby body or rapidly ejected material from a supernova.
Could you give us some examples of these triggers for star formation?
Absolutely. Take the Tarantula Nebula in the Large Magellanic Cloud, for instance. It's a collapsing cloud of gas with recent supernovae inside, which trigger the collapse of different parts of the cloud. Or consider Messier 82, also known as the Cigar Galaxy. It's being transformed into a galaxy-wide starbursting region due to the severe gravitational influence of its larger neighbor, Messier 81. However, the greatest trigger for star formation is during what astronomers call a major merger. It's like a cosmic ballet, with matter dancing to the music of gravity, forming stars, galaxies, and all the grand structures we see in the universe today. You see, it's quite the cosmic dance between elements, symbolizing a grand ballet of creation and evolution. When two galaxies of comparable mass meet and merge, there's a massive wave of star formation, which we call a starburst. These starbursts are the grandest displays of star formation in the universe, and even today, they can be witnessed. Picture the Cigar Galaxy, or as astronomers call it, Messier 82, with its stars, gas, superheated galactic winds, and the distortion induced by its interactions with its larger, more massive neighbor, Messier 81. But this doesn't mean that star formation is a continuous, never-ending process. Most of the significant mergers have already taken place and are part of the universe's history. The universe's expansion and gravitational attraction are in a constant battle, and surprisingly, gravity has been losing for a long time. In a universe completely made of matter, where the initial expansion rate and matter density balanced each other perfectly, we'd witness an endless series of major mergers. We'd see star clusters merging into proto-galaxies merging into young small galaxies, those galaxies merging into large spirals we have today, spirals merging to form giant ellipticals, spirals and ellipticals falling into clusters, and so on. There would be no limit to the cosmic web's growth. Now I want you, our listeners, to pause for a moment and imagine that. A fractal-like universe, with structures repeating infinitely as we scale up. It's absolutely mind-blowing, isn't it? However, this is where I need your thoughts. What do you make of all these cosmic curiosities? Are you as fascinated as I am? How does it feel to peer into the vast, mysterious cosmos and understand its workings? Don't forget to let us know, and stay tuned for more amazing discoveries about our wonderful universe. Now, if we look at modern cosmology, we see a vast web of dark matter and normal matter that permeates the universe. On individual galaxy scales, the structures that matter forms are highly nonlinear. But the universe as a whole is far more uniform.
So you're saying, on larger scales, everything averages out?
Exactly. On scales larger than a few billion light years, the density of any region is very close to the average density, to about 99.99% accuracy. However, fans of new star formation might be disappointed. You see, our universe doesn't contain enough matter for continuous star formation. Moreover, most of the matter isn't star-forming material, it's dark matter.
And the dark energy plays a role here too, right?
Absolutely. Most of the universe's energy isn't in the form of matter at all, but dark energy. This dark energy is driving cosmic structures apart and limiting the formation of large-scale structures beyond the scale of galaxy clusters. The new stars in our universe will most likely come from major mergers of already bound structures, the steady star formation within spiral arms, dusty disks, the infall of molecular gas, and recycled, gas-rich reservoirs of material within galaxies.
So the process of star formation is a lot more complicated than just galaxies colliding.
Indeed. Numerous factors contribute to star formation, and by modeling these, we can chart the star-forming history of our universe, from its inception to the present and beyond. The evolution of the universe and star formation rate is on full display in regions surveyed by the James Webb Space Telescope.
All this talk about galaxies, star formation, and the vastness of the universe takes me back to when I was a little girl. I remember sitting on our small porch on clear nights, looking up at the twinkling stars and trying to imagine what was out there. I would make up stories about distant galaxies, about stars being born and dying, even though back then I didn't really understand what that meant. It's fascinating to think that these views of the universe, which were just the stuff of a child's imagination a few decades ago, are now within our grasp. I mean, we're talking about understanding how the first stars formed only 50 to 100 million years after the universe's birth, how the earliest galaxies were formed around 200 to 250 million years old, and how the largest galaxies grew to a few billion solar masses when the universe was just 400 to 500 million years old.
Yes, it's truly incredible, isn't it? Larger galaxies began to influence each other, and major mergers became common. The cosmic web became denser, and this caused the star formation rate to increase over time. But interestingly, after about 3 billion years, the star formation rate steadied and then slowly began to drop.
That's intriguing. So the star formation reached a peak and then started to decline. Why is that?
That's a good question, and probably one that many astrophysicists would love to answer definitively. Even though star formation remained relatively high, about 80% of its maximum value until the universe was around 5 to 6 billion years old, the decline from its peak is noticeable. It's intriguing to ponder what might be the dominant factor at play, causing the star formation rate to steadily decrease over time.
It's like a cosmic mystery waiting to be solved. And to think, it all started with a little girl on a porch, looking up at the stars and imagining what could be.
So the decline in star formation isn't due to just one factor, but several working together. Stars, you see, are primarily formed from hydrogen and helium gas, which collapse and ignite nuclear fusion. But this fusion process also increases internal pressure in molecular clouds, pushing out much of the material that could have gone into forming more stars. Furthermore, as galaxies clump together in groups and clusters, their gravitational pull increases, attracting more material to the intergalactic medium. This means, as galaxies move through denser regions of space, much of the potentially star-forming material gets stripped away.
So the material that could have formed new stars ends up in space between the galaxies.
Right. And interactions between rapidly moving galaxies and the material in these denser regions of space can eventually remove all the gas within a galaxy, eliminating its ability to form new stars. This is a process known as ram pressure stripping. Moreover, as time goes on, the material in these galaxies becomes more heavily processed and enriched with heavier elements. A recent study found that the process of forming stars today is not the same as it was in the past. The older a star-forming galaxy is, the longer it takes for them to complete their star-forming periods.
It's like the universe is becoming more refined in the way it forms stars?
You could say that. The new study discovered that it takes a galaxy longer to stop forming stars as the universe ages. Only 1.1 billion years when the universe was young, 1.3 billion years when it was middle-aged, and 5 billion years in the present day. The universe, it seems, has its own rhythm for star formation. So, to put all this together, star formation in the universe is not a constant process, but one that changes over time. It's like a cosmic ballet, where the dancers, or in this case, new stars, emerge onto the stage faster at the beginning and then gradually slow down. Add to this the effect of dark energy, which restricts the formation of additional structures, and we have a very quiet universe. The star formation rate today is just a fraction of what it was at its peak, only about 3 to 5%. In fact, the majority of stars were formed in the first approximately 5 billion years of our cosmic history. Only about 15% of all stars at maximum have formed over the past 4.6 billion years.
That's a surprisingly small number. So the universe has truly slowed down in terms of star formation?
You're right, and it gets even more detailed. In terms of numbers, a total of 2.21 sextillion stars have formed over the history of our universe, at least within the part of the universe we can observe. But if you look at the universe at different ages, you'd find that the distribution of star formation is quite varied. For instance, 98% of the current number of stars had formed by the time the universe was 12.9 billion years old, 75% by the time it was 7.3 billion years old, and so forth. Today, the star formation rate is a mere shadow of what it once was. In fact, the star formation rate has declined by a staggering 97% since it reached its maximum 10 to 11 billion years ago.
It's fascinating and a bit humbling to think of the universe in these terms. It really puts into perspective how vast and dynamic it is, doesn't it?
If we delve deeper into our cosmic history, we see that star formation was much more robust in the early universe. We can see this through profound glimpses provided by space telescopes like Hubble that take us back to a time when most of the universe's stars hadn't even formed yet. An interesting thing to note about our star formation history is that the greatest uncertainties are found in the earliest times, the first 1 billion years. However, that period only accounts for around 1% of all stars formed. Hence, our uncertainty in the total number of stars that have ever formed is actually very small.
So the majority of star formation happened when the universe was between 1.5 to 8 billion years old.
Correct. And while the star formation rate has been declining for more than 10 billion years, it's only over the most recent approximately 5 billion years that the decline has accelerated dramatically. We can even estimate that more than 95% of the total stars that will ever form have already been created. However, as long as there is gas remaining in the universe and gravity continues to do its thing, there will always be opportunities for new stars to form. When a cloud of gas collapses, only about 10% of that material ends up in stars. The rest goes back into the interstellar medium for another chance in the distant future.
So we can expect to continue forming new stars for trillions of years.
Exactly. However, even with that said, new stars are much more of a rarity now than at any point since the universe was in its early stages. But as we continue to gather more data from the James Webb Space Telescope, ALMA, and other far-reaching telescopes, we are gradually uncovering the last uncertainties in the cosmic story of stars. So we've taken a deep dive into the cosmos, unraveling the secrets of star formation. From the early universe, where stars were metal-free and massive, to our current universe, where star formation is at its lowest point in over 13 billion years. We've discussed the triggers of star formation, the decline of the star formation rate, and even the estimated total number of stars that have ever formed in the observable universe. Quite a journey, isn't it? But remember, as long as there are gas and gravity left in the universe, star formation will continue, even though it's a rarity now. We might be witnessing a slower cosmic ballet, but the dance of the stars continues, with new dancers poised to emerge on the stage. Just think of that next time you gaze up at the night sky.
And with telescopes like the James Webb Space Telescope and the Atacama Large Millimeter Array, we're finally pinning down the last uncertainties in this grand cosmic story. It's a testament to human curiosity and our incessant drive to unravel the mysteries of our universe. If you've enjoyed this cosmic journey with us, please don't forget to blast that like button. Leave your thoughts in the comments and share this episode with your friends. Spread the love and the knowledge.
Yes, let's keep our heads in the clouds, or rather in the stars. Thank you for joining us on this journey. Until next time, keep exploring, keep questioning, and never lose your sense of wonder about our amazing universe.
And as always, thank you for tuning in to our Curiosity Wonderland. Goodbye, everyone.
Goodbye, and remember, the universe is full of surprises. Stay curious. We've been diving into the subject based on an article titled, "What Was It Like When the Universe Formed the Most Stars?" written by Ethan Siegel, published on January 2nd, 2024 on the Big Think site. If you want to explore this topic further, find the full link in our episode description. So now I'm off. Until next time,